Okay, welcome to this video. We're going to be having a look at a practice paper 3 for the higher tier exam. As always, you can get back to the video by scanning the QR code on the front of the booklet, which you can download in the description. You can also use the chapters feature to skip through to any questions that you'd like to come back to. Now we're going to get started straight away, as we have a lot of questions to get through here. So for this first one, we are asked to find a class interval that contains the median from this grouped frequency table. Now if we work down this group frequency table, we essentially just want to find where that middle person is. And if there are 60 days, and this one is about the amount of days rather than people, we want to find where that 30th person or that 30th day is, depending on the context of the question. Now if we count down the rows that we have, you can see in the first row we have 8 days. And then if we cumulatively add these together, by the time we get to that second row, 8 plus 24 will get us to the 32nd day. Now if we have gone past the middle, then therefore the middle must be in that particular section. So the median would be in this class here, just on the left, so we would just write down the full class there, which is between 5 and 10. And there we go, that is where our median lies. For part B, it is asking us to draw a frequency polygon for this information. Now with a frequency polygon, we plot the points on the midpoints of the classes. So between 0 and 5, our midpoint is 2.5, and they all follow a reasonably logical pattern here. So 17.5 and 22.5. Now if we have a look at the graph, those midpoints are relatively nice to find because they're just in between these numbers here. So we just need to plot the heights on those midpoints. So we have 8, 24 and 13. So 8, 24, which is here, and 13, which is here. And then for our next one, we have 11 and 4. So 11 is just above the 10, and then 4 is just down here. Now to join up a frequency polygon, it is just a dot to dot from the first dot over to the second, and then following that nice logical straight line join up. There we go, and let's make sure our lines look nice and straight when we join them up. So you should be using a ruler for this. There we go, and just making sure those are really nicely connected and trying to draw it as perfectly as you can. And there we go, there is a frequency polygon for question 1. Question 2 here is looking at some compound interest. So it says here, Farah invests £8,000 for 3 years in an account paying compound interest. In the first year, the rate of interest is 3%. From the second year, the rate of interest is 1.5%. Work out the value of Farah's investment at the end of 3 years. So to start with here, we can either use the percentage button on our calculator, and I'll link a video in the description so you can see how to do that, or we can turn these into multipliers. So with 3% in the first year, we will then have 103%. And if you type that into your calculator using your percentage button, or just divide that by 100, you will get your multiplier, which is 1.03. We want to do the same for the 1.5%, which would be 101.5%, and either using that percentage button or dividing that number by 100, which gives you 1.015. So nice and easy. Now we just multiply by our multiplier. So 8,000 times 1.03 will do the first year, and then multiplied by 1.015 will do the second year. We do get that 1.5% for an additional year, so rather than typing in times 1.015 again, we can put a power of 2 with that second one. So now all we need to do is type it into the calculator, so times 1.03 times 1.015 squared with that one, and that gives us a final answer of 8,489.054. And just remember to round that to the nearest penny, so 8489.05. And there we go, that is the value of Farah's investment at the end of the 3 years. Okay, so question 3. We have some density, mass and volume. Now you need to use your formula here. Density is equal to mass over volume, and you might also use a formula triangle. So density is equal to mass divided by volume. Now here it wants us to work out a volume. So if we cover up the volume and essentially rearrange our formula, it is the mass divided by the density. The only thing that you need to check is that the units are the same. So for our mass, we are given kilograms, and our density is given in grams. So we want to convert this into grams, And remember, the word kilo means 1,000. There are 1,000 grams in a kilogram. So we'll multiply this by 1,000. Again, you can do this all on the calculator. So times by 1,000 and you get 12,500 grams. From there, we just need to put it into our formula. So it's mass divided by density. So 12,500 grams, which now matches our 19.3 grams per centimetre cubed. We'll type that into our calculator. So divide by 19.3. And that gives us 647.66839338. Now this question here says to round my answer to 3 significant figures. So 647 is my third significant figure, and after that is a 6, so it's going to round up. So 648, and that is in centimetre cubed. So that was a volume, but centimetre cubed is on our dotted line here, so 648 is our final answer. We don't need to put the units in there, of course, if it's already given to us. So there we go, that was looking at density, mass and volume. On to our next question, and we are looking at some sampling. It says here, each person in a fitness club is going to get a free gift. Stan is going to order the gifts. He takes a sample of 50 people, which we can see there in the table, and he asks each person to tell him the gift they would like. It says that there are 700 people in the fitness club. How many sports bags should Stan order? Now, there are 2 different ways of doing this, but essentially we know that there are 50 people in total in the sample. It tells us that in the question, just here. However, of course, if it doesn't, we can add it up from the table there. Now, we essentially want to know how many we're going to need for 700 people. Now, we can find that out relatively easily by just thinking about what we need to multiply to get from 50 to 700. Of course, you have a calculator, so we can do 700 divided by 50, and you can type that in on your calculator, and we get the answer 14. So we need to multiply all of these by 14, but of course, we only actually need to look at the sports bags here. So 17 multiplied by 14 would give us our final answer, and that comes out as 238. So our final answer would be 238. The other way that you could approach this is you could think about it as a fraction of an amount. It's essentially doing exactly the same maths, but we have 17 out of 50 that want the sports bag. So to work out 17 50ths, we would divide by 50, which is exactly what we did just here to find 14, and then multiply our answer by 17, which is exactly what we did just here. So it's exactly the same maths, it's just a slightly different way of looking at it and approaching it. But we get the same answer either way, 238. Just remember, with these samples, we are assuming that the sample represents the rest of the population or the rest of the people in the sports club. And of course, if the sample does not represent the rest of the people, our answer could actually be bigger or smaller. But this question here was just asking us to work it out. Now, question 5, this kind of exchange rate question, does tend to throw people as it has conversions of units in there as well. Now, when we approach this sort of question, the 2 scenarios which we have here, which is the price of petrol in Spain and the price of petrol in Wales, we just need the same currency and the same units for each particular example. So it's up to you how you lay this out. I quite like just to sort of split the page up and look at the 2 different scenarios. So we have Spain and we have Wales. Now in Spain, we have 27 euros, and that is 18 litres. Now for starters, typically in every question, we'll try and convert it to the home currency, in this case, the pound. So we are given the conversion here. €1 is 0.85 pounds, or in other words, the pound number is going to be smaller. So to ensure that we get that, we need to multiply this by 0.85, and that is going to turn our 27 euros into pounds. We'll know it's correct because we'll get a smaller number, and that comes out as £22.95. Now remember, all we are doing in that step is changing the currency. So we're not changing the amount of litres here, it's still 18 litres, but we are paying £22.95. Now when we are looking at comparing these 2 things, as it wants to know where is cheaper, we want to compare 1 litre. So if we want to now compare 1 litre, well, to get from 18 litres to 1 litre, we of course have to divide by 18. And in this scenario, we're going to divide both sides by 18, because we are going down to just 1 litre now. So £22.95 divided by 18, and that gives us £1 and just over 27p. So £1.275, and that is equal to 1 litre. So that is the cost per litre in Spain in pounds. We're now going to have a look in Wales. So in Wales, it says it's £40 and 80 pence, and that is equal to 8 gallons. So here we are already in pounds, so we're in the correct units, but here we have gallons. Now if we want to convert that into litres, and of course you could have converted this question, you could have put both of them into gallons, but litres tends to be the units that we use in England, so we'll convert this to litres. So for litres here, we want to multiply the amount of gallons by 4.5, as every gallon is 4.5 litres. Now again, we're not changing the price here, it's the exact same amount of petrol that we are getting, except we are now writing the units in litres rather than gallons. So 8 times 4.5 is 36 litres. We now have this same scenario where we are in pounds and we're in litres, but we want to know the cost of 1 litre. So to get the cost of 1 litre, we would divide by 36, and we're going to do that to both sides this time as we are now going down to 1 litre. So £40 and 80 pence divided by 36 is equal to, and it comes out as a recurring decimal, but it's 1.13 with a dot above the 3, and that is now 1 litre. Now it doesn't matter that's a recurring decimal, because if we round this to the nearest penny, in Spain it's £1.27, and in Wales it's £1.13. Or if we follow our rules of rounding, it'd be £1.28 in Spain. So it says here, Sam thinks that petrol is cheaper in Spain than in Wales. Is Sam correct? You must show how you get your answer. Now it does ask us this question here, is Sam correct? So we need to answer that question. So we would say no, Sam is incorrect or not correct. And we have all of our working out to back that up. So we could say another statement there. We could say the petrol is cheaper in Wales, but of course by saying he's not correct, then we are saying it is the opposite. So there we go, no, Sam is not correct, and we have all of our working out to back that up, and our big important number there is that £1.13. So there we go, that is some currency conversions, where we also have some unit conversions involved as well. Okay, on to question 6, and we have a scatter graph. It says here the scatter graph shows the information about the amount of rainfall in millimetres and the number of hours of sunshine for each day of 10 English towns on the same day. So on the left we have the amount of hours of sunshine, and on the right we have the amount of rainfall. It says one of the points is an outlier. Write down the coordinates of this point. Well, you can see that a lot of these points follow quite a similar trend, and I quite like to draw a line of best fit in straight away when I have a scatter graph, and it's going around about this sort of direction here. And remembering line of best fits can be very varied, so it is okay if your line of best fit was not exactly the same as mine, but you're typically looking for around about the same amount of points above as below. And arguably I could angle this in a slightly different way, but that there is absolutely fine. Now there is one point which is quite far away from that line of best fit, and it's this one just here. So this one here is called the outlier. So that point, it acts as a coordinate, so the x coordinate just below that is 2, and the y coordinate just to the side is 1. And there we go, that's the coordinate for our outlier. For part B, it says ignoring the outlier, describe the relationship between the amount of rainfall and the number of hours of sunshine. This is quite an interesting one here because it says describe the relationship. Now if it said describe the correlation, well in that case we only normally need to give one word. We either say positive or negative. And this one here has a negative correlation. But this particular question says to describe the relationship. So when we are describing the relationship, we're going to use the words that are on the axes. So here, the amount of rainfall and the number of hours of sunshine. So what's actually happening in this scenario? As the sunshine is increasing, what's happening to the amount of rainfall? Or on the flip side, as the amount of sunshine is decreasing, what's happening to the amount of rainfall? Well, you can kind of pick two of the points to actually see that. You can see up here where we have a lot of sunshine. Let's have a look at this top point. We only have less than 2 hours or less than 2 millimetres of rainfall. Whereas if we look at a different point, let's have a look at this one, the lowest down here, when there's 1 hour of sunshine, there was 6 millimetres of rainfall. So what we're seeing there, and this is what the negative correlation means, is that as one goes up, the other goes down. So here, the number of hours of sunshine, as the number of hours of sunshine increases, the amount of rainfall decreases. So we could say here, as the hours of sunshine increases, the amount of rainfall decreases. And there we go. You could also say that on the flip side. You could say it the other way around. So as the amount of hours of sunshine decreases, the amount of rainfall increases. But there we go. We've gone for this one. As the sunshine increases, the amount of rainfall decreases. And there we go. We have described that relationship. For part C, it says on the same day, in another English town, there were 7 hours of sunshine. Using the scatter graph, estimate the amount of rainfall in this town on this day. So 7 hours of sunshine. So we want to go to 7 hours of sunshine, which is between 6 and 8. We're going to draw a nice straight line across to our scatter graph. We're going to hit that line of best fit that we've drawn in with a ruler. And then we're going to draw a line coming down. And we're going to read that as best as we can. Most importantly, showing it on our graph and showing that we have read using our line of best fit. So in the middle of 2 and 4, we have the number 3, which means each of those squares goes up by 0.2. So that's going to be 3.2 just after that, because that'll be 0.2, 0.4, 0.6, 0.8. So it goes up in 0.2s. So my answer there is going to be 3.2. So there we go, 3.2 millimetres. And of course, you can have a varying amount of answers or varying answers for that question, because your line of best fit can be different to somebody else's. So there we go, I've got 3.2 for mine. This next question is looking at a prism. And it's asking us to draw a front elevation and a side elevation. And there we go, we are given a centimetre grid. This question is quite a tricky one because it says to use a scale of 2 centimetres to 1 metre. So we're going to need to think about this one very carefully when we draw it, as the measurements on this diagram here are not given to us in centimetres, which is going to make drawing it on a centimetre grid a little bit trickier. So it says here that 2 centimetres to every metre. So, for example, if we look at a nice easy length, because we do have some not so nice ones here, 2 metres would be double the 2 centimetres, it would be 4 centimetres. So the base there is going to be 4 centimetres. Now thinking about what we've done there, essentially all we've done is times by 2. So if we multiply all of these lengths by 2, they will turn into the amount of centimetres that we need to draw. So the top one here will be 4 centimetres, or the height of that shape there. 0.5 times 2 is going to be 1 centimetre. This is going to be 2 centimetres. This 0.5 here is also going to be 1 centimetre. And if we have to draw this diagonal line, 2.5 times 2 will be 5 centimetres. Now, it asked us to draw the front and the side elevation. Now, the front elevation is giving us a nice arrow pointing towards this shape, and it's this trapezium shape just here. So we won't see any of the other sides, we just need to draw this particular face, and that right there is our front elevation. So we need to draw this trapezium, and it needs to be 4 centimetres high on the left. So let's just start by drawing a 4 centimetre high line. It's 4 centimetres across, so 1, 2, 3, 4. We have 1 centimetre going up, and there's our 1 centimetre, and then we need to connect those together with this diagonal line, which we don't need to measure there because it's the final line that we have to draw. And there we go, there is that trapezium drawn. And it all kind of fits together and makes sense. And if you want to label the plan or the front or the side in any of these diagrams, you can label them, but it doesn't ask us to. Now for the next piece that we need to draw the side elevation. Now the side elevation is of course looking at it from the side. So the first thing that I'm going to draw is I'm going to draw this smaller rectangle just down here, this nice flat face that we would see down the bottom. Now that there has a height of 1 and a width of 2. So I'm going to draw that in to start with, and I'm going to draw it right next to this shape that we've just drawn. And I like to draw them next to each other, particularly when we're asked to draw both, because I know that they need to be the same height. And there we go. How far across were we going? 2 centimetres, not 4, so always go back and check. So 2 centimetres across takes us to here, and then joining that up, and there we go, that's that bottom part. Now this sloping side that we will see can look a little bit complex to draw, but essentially all we need to do is look at this height that it gets to up here in these top 2 corners, and it gets to that height of 4 centimetres. So although that's slanted from the side when we look at it, if we are drawing it as a 2D sort of elevation, we would just see a rectangle going up like this. There we go. And of course, that's slanted, but that's where we would see those top two corners, which I put those dots on, would be just there. And there we go. That is our front elevation and our side elevation. And as I said, it's very nice to draw them next to each other because you know that that height has to be the same, regardless of which orientation we're looking at. So there we go. There is a plan and elevation while also using some scales. So this next question, we are looking at pressure, force and area. Now it says here the total surface area of the cube is equal to the surface area of the cuboid. The pressure on the floor due to the cube is 2.35 newtons per centimetre squared. Work out the force exerted by the cube on the floor. So we have our formula up here and it tells us the pressure. So we know the pressure is 2.35 and that is equal to the force divided by the area. Now we're trying to work out the force, so we must be able to get this area. So before I start putting any numbers in there or writing the word area, I'm going to come to the shapes and see if I can figure it out. Essentially I want to know the area of this face on the bottom of the cube. Now it tells us that the total surface area of the cube is equal to the total surface area of the cuboid. So I need to work out the surface area of that cuboid. So I'm going to start by having a look at the different faces. So I have this front face here, which would be 6 times 8. I'm going to put this in brackets because I also have another side to look at, and that's this one just on the side here. Now that one there, which has a height of 6 and a length of 18, so that would be 6 times 18. And I have one more face that I need to look at, and that's the top one just here, and that would be 8 times 18. And I do quite like working out the surface area of a cuboid because as you can see, those pairings of numbers in each bracket are all different pairings. So unless one of the sides is the same length, it is quite nice to find that surface area. So we're going to add these together. 6 times 18, add 8 times 18. There we go. And that comes to 300. Now it's up to you how you work this out. Of course, there are two faces that are the same on the front, the back, the sides, and the top and the bottom. So for the total surface area, I need to multiply my answer by 2 because I've only worked out one of each of the faces. So if I times that by 2, of course I get the answer 600 centimetres squared. That's the surface area of the cuboid, which of course therefore is the surface area of the cube. Now if the cube has a surface area of 600 centimetres squared, then to find the area of one surface, I would need to divide that by 6. Because of course all of the faces on a cube are identical or equal in size. So I'm going to divide this by 6 and that will give me an area of 100 centimetres squared, and that is the area for the base of the cube. So now I know the area of the base, I can put that into my formula. 2.35 is equal to the force divided by 100, being that base area of the cube. If I want to know the force, I just need to rearrange this formula by multiplying by 100, which is a really nice number to have to multiply by, because I don't really need to use the calculator for that. It does just move that decimal 2 places to the right. So 235 is equal to the force. So there we go, my answer is 235 newtons. And there we go, that's my final answer. Looking at the surface area of a cube and a cuboid and using that to work out the force in our pressure force area formula. Of course, not forgetting as well, you can use a formula triangle for pressure, force and area. Pressure is equal to force divided by area. And there we go. You can always rearrange it if that makes you feel a little bit better with this. You cover up the force and it was the pressure times the area. Okay, so on to our next question. Now for this one we have a stem and leaf diagram and it says on the grid, draw a box plot for this information. So when we have this sort of information in a stem and leaf or otherwise, I always tend to plot the smallest and the biggest first. So here we can see the smallest value is 17. Check the scale really carefully. But there we go, 17 is just there, it goes up in ones. And then this number here, 41, is our largest number. I'm going to draw that one in as well. Not forgetting what a box plot looks like. We have this box in the middle that we need to draw with our median, and then our lowest and highest value. So the next few bits that we need to find are a little bit more complex to find. The easiest way to find them is to add 1 to the amount of people, and then divide that by 2 to find the median, and add 1 and divide it by 4 to find the quartiles, or the quarter wherever we're looking. So 26 divided by 2 will be the 13th number, and 26 divided by 4, not so nice there, but 26 divided by 4 is the 6.5th number, which is in between the 6th and 7th. So for the median here, if we're finding the 13th number, we can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the median is on 28. So let's find 28, and let's just mark that one in. That's our median, and now we just need to find our quartiles. So with the quartiles, we need to find the 6.5th position, which seems a little bit strange, but we are essentially finding the number that is therefore in between the 6th and 7th, going from the start and also going from the end. So if we go from the start, and I'll circle them this time, 1, 2, 3, 4, 5, and then we have the 6th and the 7th just here. So 1, 2, 3, 4, 5, 6, and we're looking at the 6.5th number. So that's in between 22 and 24. Now in between 22 and 24, we have the number 23. So we are looking in between 22 to 24. The middle is 23. And that's where our lower quartile is. So that would be just here. And once we've drawn that in, we can actually start to complete the first part of our box plot. We now need to find the upper quartile as well. So 1, 2, 3, 4, 5, 6, and then it's between these two. So that is between 32 and 33. We do get a decimal for that, so that will be 32 and then 0.5. That's a little bit more awkward to draw, but it's fine. We're going to find 32 and 33, and we're going to draw a line in between those two just there, and therefore connecting our box plot and finishing it all off. And there we go, that's how we draw a box plot. We actually had to find the quartiles in the stem and leaf within this question. Of course, you might just be given the quartiles, or you might be given the range or the interquartile range to find the distance between the quartiles. But there we go, there are the quartiles and the median from a stem and leaf, and using those to draw a box plot. Okay, onto some algebraic fractions. Now when adding or subtracting algebraic fractions, you need a common denominator. So here our common denominator is going to be in terms of algebra. Now to do this, we need to multiply the left fraction by our right denominator, which is x minus 4, and I like to write that in a bracket. And our right fraction we're going to multiply by our left denominator, which is x plus 2. Now when we do that, you can write that out in full if you want. It means on the top of the left one, we'll have x lots of x minus 4 on the top. On the bottom, we're going to have a double bracket, so x plus 2 and x minus 4. On the right fraction, when we add that together to this, we are going to have 2x on the outside of the bracket and x plus 2 on the inside of the bracket. And again, we've got our double bracket on the bottom, x plus 2 and x minus 4. Now, we do have a common denominator now, but we need to expand the numerators and add it all up. So let's expand these out. There we go, and we'll write that out. We can write it up here to save ourselves writing it over and over again. We have x squared minus 4x for our left numerator, and 2x squared plus 4x for our right denominator. Now if we look at what we have on the numerators now, we have an x squared, which we are adding to a 2x squared. So our new numerator will have a 3x squared, and we also have this minus 4x and a plus 4x, and they actually cancel each other out, so we're not going to have any x's on our numerator. So our numerator's done, we just have the 3x squared. On the denominator, we have this x plus 2 and x minus 4, and we do not need to expand that. It's already factorised, so this allows us to see if there are any common factors top and bottom. There's no common factors that go into the numerator and the denominator there, so that would be our final answer. You can, if you want, expand the denominator, but you're not going to gain any additional marks for that. So if you don't need to expand it, then why bother? But of course, if you write it expanded, it's absolutely fine. You're going to get the same amount of marks, you're just going to have to do a bit more work for it. So there we go, I'm going to leave it factorised, and there's my final answer, 3x squared over x plus 2 and x minus 4. Okay, so relatively nice algebraic fraction. We've now got a product rule for counting question. It says here Kira is going to buy a new car. For the car, she can choose one body colour, one interior colour, and one wheel type. She can choose from 17 different body colours, 28 different wheel types, and the total number of ways she can choose the body colour and the interior colour and the wheel type is 2,856. Work out the number of different interior colours that Kira can choose from. So here, with the product rule for counting, we just take all of the different options that we have and multiply them all together. However, we are missing that final one. We do not know the interior colour. So if we start by multiplying the two that we do have, we have 17 times 28. And if we work that out, of course, just typing it in on the calculator, 17 times 28 is 476. Now we want to know what the final one is, or what you multiply 476 by to get to this 2,856 total. Now we don't need to try and figure that out. Of course, we can just do a division. So 2856 divided by 476. And if we type that into the calculator, we get a final answer of 6. So our answer would be 6. There would have to be 6 different interior colours in order to ensure that we can hit that total of 2,856 different combinations. Okay, so there we go. Our answer was 6 for that one, and that's just the product rule for counting, and just recognising when it is a product rule question and we're looking at all these different combinations and trying to find out how many sort of options there would be, or in this case here, trying to find out from the amount of options what there would be for just one of those individual things, and in this one it was the interior colours within that car. So question 12 is a functions question. Typically doesn't tend to appear as early in a paper, but this is a relatively nice function question. We have using a function, we have an inverse function of a relatively nice function to rearrange, and then we have a relatively nice composite function as well. So obviously you can get some pretty hard functions questions. Now what I will do is link, obviously in the description, a link to some much harder versions of this, but a relatively nice functions question for us to work on. So for part A, it says to do the function of 10, which means we're going to use the f function, which is right here. And typically, if there's any brackets involved, we're going to want to expand that. So that'd be 3x minus 12. There we go. Now that makes substituting into it a lot easier. So we have 3 lots of 10 minus 12. You can do this on the calculator if you want, but that's just 30 take away 12, which is 18. So we just get 18 for part A. Not the trickiest question there. For part B, we have an inverse function, and we want the inverse of g. G is up here. You might have different methods for this. I write it as y equals x plus 5 over 1, x over 5 plus 1, and then rearrange it to make x the subject. Now to do that, you've got 2 options. We can multiply by 5 first, as long as I remember to times the 1 by 5. I like to get rid of that 1 to start with, so minusing 1 from both sides. And that gives me y minus 1 is equal to x over 5. At this point now, I would like to multiply by the 5, and then I can write that either as a single bracket. I could write 5 lots of y minus 1 is equal to x, or I can go ahead and expand that bracket. I don't necessarily have to expand the bracket. Typically when I'm dealing with functions, I do tend to expand them, but ultimately I need to swap the x and y, so y is equal to 5 lots of x minus 1, and there we go, that's my inverse function, 5 lots of x minus 1. If you want to expand the bracket, absolutely fine. I'm going to leave it factorised because at no point does it tell me it's got to be expanded or written in a certain form, so always fine to leave it factorised. Now part C here is asking us to do a composite function, a relatively nice one as well because it's ffx, so we don't have to necessarily think about the order in which we do that. Remember though, if it was gfx, you have to put the f function into g, and if it's the other way around, fgx, you've got to put the g function into f. But here with ffx, we just have to put the f function into f. Now the f function is 3x minus 12. So I'm going to write that down here. So we have 3x minus 12. And if I'm going to substitute the f function into the f function, I put it here where the x is. So in place of the x, I need to put another 3x minus 12. And if I write that out, so we have 3 lots of 3x minus 12 instead of just x, and then minus 12 at the end. I just need to expand and simplify that. In this case, I do need to expand and simplify because it wants me to show that it equals 9x minus 48. So if I expand the bracket, we get 9x minus 36, and then minus another 12. And if we simplify these two numbers, we get 9x minus 48. And there we go. A relatively nice question of functions, just looking at all those different processes. So do make sure you're nice and happy with inverse functions and composite functions, especially when we have different letters here, like gfx or fgx. And just make sure you're happy with the order in which they are done. But there we go, some functions. Next one, Stefania bought a new car 3 years ago. At the end of the first year, the value of the car had decreased by 12.5%, and the value of the car then decreased by 10% for each year for the next 2 years. At the end of those 3 years, the value of the car was £17,010. Work out the value of the car when Stefania bought it 3 years ago. So ultimately, we have a value of the car. Let's call that x. Now, each time it had decreased, we would multiply it by some form of multiplier. To find that multiplier when something's going down, we need to subtract the percentage away from 100%. So 100 take away 12.5% is 87.5%. For the next one, where we have this 10%, well, 100%, we probably don't need to write this down, it's quite obvious that that's 90%, but 100% take away 10% is 90%. So essentially, the calculation that we would do is x multiplied by, and then the multipliers for those percentages. Now you can either type the percentage into a calculator and press your percentage button, or you can divide them by 100. So if we divide them by 100 or type them in as a percentage and press equals, our multiplier for the 12.5% decrease is 0.875. And then for the next one, it's 0.9 for 90%. But that one was for 2 years, so that would have a power of 2 with it. Now, it tells us the answer. It tells us the answer for that is £17,010. But we want to work out what this original amount was that we were multiplying everything by. So in order to work this out, we can either divide all these pieces over in multiple steps, or we could just do it all in one step. So I could divide both sides by 0.875 and divide by 0.9 squared, and we can do that all in one jump, which would leave me with x is equal to £17,010 divided by 0.875 times 0.9 squared. If you're not happy to do that and move it all over in one go, of course you can just divide each piece over individually, but if you're happy to just jump everything underneath there, it's going to save you a little bit of time. And if we type that all into the calculator, we get £24,000. There we go. You can check that out as well. You can put 24,000 back into the original amount, times it by 0.875, times it by 0.9 squared, and you will get £17,010. And there we go, a very similar process to when looking at compound interest. It's just that this time it's going down in value, so our multipliers are 0 point numbers rather than those 1 point, and there tends to be quite small percentages with compound interest, like 1.03 and things like that. So there we go, that is a depreciation question where something was going down in value. For question 14 here, we have a capture recapture. So it says Saffron wants to work out an estimate for the total number of fish in a lake. On Friday, Saffron catches 180 fish. She puts a tag on each fish and then puts them back into the lake. On Saturday, she catches 305 fish and finds that 45 of them are tagged to work out an estimate for the total number of fish in the lake. Now what we're going to do is write a proportional fraction or pair of fractions which show these two captures. So in the first capture, she captures 180 fish and we don't know out of how many. So we put the letter X or any unknown letter there. That has to be equal to, proportionally, another fraction in the second capture. So on the second capture, she catches 305 and 45 of them have the tag on. So 45 out of 305. Now this fraction on the right, we now have the proportion for. And if we want these to be equivalent fractions, we just need to figure out what do I have to multiply by to get from 45 to 180. So of course, to the side, we can do 180 divided by 45. That's going to tell us what we need to multiply by. Now that comes out as 4. So we need to multiply the numerator by 4, and when creating an equivalent fraction, of course, we multiply the denominator by 4 as well. So 305 multiplied by 4, that gives us our final answer, and that comes out as 1,220. And there we go, that is just comparing that first capture to that second capture and ensuring that we have two equivalent fractions there. Of course, this is only an estimate because things can happen in this process. For example, the fish are having tags put on them, and some of those tags could have fallen off in between the two captures. So we are assuming things like that haven't happened. We're assuming that the tags have not fallen off, otherwise that could have affected our answer. So on to question 15, we have some perpendicular line equations. So for this one here, we are told that a straight line L has the equation 3y is equal to 4x plus 7, and point A has the coordinates 3 and -5. It wants us to find an equation of a straight line that is perpendicular to L and passes through A. So here, to start with, we need this equation in the form y is equal to mx plus c, and we need it in that form so that we can see the gradient. If we are looking at a perpendicular line, we can then look at the negative reciprocal of that gradient. But to start with, we're going to need to divide this equation by 3. That will give us 1y is equal to, and 4 divided by 3 we can just write as 4/3 x plus, and it doesn't really matter what the 7 divided by 3 is, so we'll just leave it as 7/3. We only really care about this gradient. So the gradient is 4/3. Now, if the gradient is equal to 4/3 for line L, well, our perpendicular line will have the negative reciprocal of that, which will be -3/4. We can now put that into our new line equation for the perpendicular line, minus 3/4x plus c. To find the equation of the line, we need to know a coordinate that's actually on that line, and we have that coordinate just here, 3 and -5. So y is -5, and that's equal to -3/4 multiplied by the x coordinate, which was 3, plus c. We just need to expand this out, find the value of c, and put it back into our equation that we've just written above. So we have -5 is equal to -3/4 times 3 is -9/4. You can just do that on the calculator, plus c. We can then add 9/4 to the other side, and again you can just type into your calculator -5 plus 9/4. And if we add that to both sides, we get our value of c. If we leave it as a fraction, we get -11/4 is equal to c. Now we've got that, we just need to put that value back into our equation to finish this off. So our final answer would be y is equal to -3/4x minus 11/4. And there we go, there is the equation of our line, which is perpendicular to L and passes through that point A. And there we go, some perpendicular line equations. For question 16 here, we have an enlargement with a negative scale factor. So it says to enlarge triangle P by a scale factor of -1.5 with a centre of enlargement -2, -1, and label your image R. Now for starters, we want to find that centre of enlargement. So -2, -1 is just here. So that's where our centre of enlargement is. The next thing is to just bear in mind, we are going by a scale factor of 1.5. A negative scale factor, but a scale factor of 1.5. So we need to count to one of these coordinates. Now to get to that first vertice on the triangle there, I would go 2 up, and I would go 1, 2, 3, 4 to the left. Now with a negative enlargement, from that centre of enlargement, I just need to do the opposite, but also take into account it's getting 1.5 times bigger. So if that's 2 up and 4 to the left, well, if I multiply those by 1.5, and you can always do that on the calculator, or you might just know that timesing by 1.5 adds an extra half on. So instead of going 2 up, I need to go 3 down. And instead of going 4 to the left, I need to go 6 to the right. 3, 4, 5, 6. Let's just count that again. 1, 2, 3, 4, 5, 6. There we go. And that point goes there. Now, you need to do that for every point. It's very rare that people can see or visualize what those look like. In terms of where the rest of the shape goes, it might be that once you've drawn one more coordinate that you can spot it, but these are quite hard to spot in comparison to all of the other transformations. So I'm going to go to this corner now, and that is 1, 2, 3, 4, 5, 6 to the left. If I add half on, that'll be 9 to the right, and then 1, 2 up, and if I add half on, that'll be 3 down. So I need to go 1, 2, 3 down, and then 9 to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And there we go. There is the base. Now, when you do a negative enlargement, it does rotate the shape 180 degrees. So just a negative or an enlargement by -1 can just be a rotation. But this one here is 1.5, so I just need to be really careful just to figure out where that final point goes. So I'm going to finish off with this top point here, and that's 1, 2, 3, 4, 5, 6 up, so I'll go 9 down, and 1, 2, 3, 4, 5, 6 to the left, so I'll go 9 to the right. So I need to go 9 and 9, which is just 6 and 6, both multiplied by 1.5. So let's make sure we've got enough space. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. And there we go. There is our final coordinate. The shape has gotten 50% bigger, or a scale factor of 1.5, adding that additional 50% on. And there we go, joining it all up. And it did say, label your image R. So I just want to put a really nice clear R in there. And there we go. There is my enlargement by a negative scale factor. And there we go, on to our next question. So for this question, we have a circle theorem. It says here, ABDE is a cyclic quadrilateral, and ABC and EDC are straight lines. Angle DBC is 60, that's given to us in the diagram. It says, given that angle EAB to the size of angle BCD is 2 to 1. Let's find those. So EAB is here, and BCD is here. And it says that they're in the ratio 2 to 1. You can either leave those as a ratio, or you can write it in terms of algebra. We can say that that's 2x and 1x. It says work out the size of angle BCD, and you must show all your working. So B to C to D is this one here. So that's the one we're looking for. Now straight away, when you are looking at a question like this, and of course there are so many different circle theorems, and I will link the lesson on all the different kinds of circle theorems in the description. But for this one here, you need to just think, is there any angle that I can find? Well, the first thing that I spot is this angle just here next to the 60. And that has to be 120 degrees because angles on a straight line equal 180. And it does say here, you must show all your working, but it doesn't say that I have to give reasons, which is quite a nice one. So if I'm going to show my working, I'm just going to write 180 minus 60 just next to that. Now, we do have a cyclic quadrilateral, and opposite angles within a cyclic quadrilateral, and here is our cyclic quadrilateral, opposite angles add up to 180 degrees, which means I can find this angle here because these both add up to 180. We've just done the working out. 180 take away 60 is 120, so 180 take away 120 has to be 60. And there we go. That's already figured out quite a lot of angles just using that circle theorem. So from here, where do we go next? Well, now we're kind of looking at a whole different shape because this has created one super large triangle there, even though it sticks out of the circle. It creates one big triangle, and it did tell us that ABC and EDC were straight lines, and therefore it is a triangle, which means that we can look at those angles on the outside of the triangle, the 2x and the 1x and the 60, and we can find those missing angles. Now within a triangle, they add up to 180 degrees. One of the angles we know is 60, so that leaves us with 120 degrees. That 120 degrees is shared between the 2x and the 1x, meaning that 3x's in total adds up to 120. If 3x's is equal to 120, then 1x is equal to 40. And therefore, x is equal to 40, and we could actually go back and fill this in on the diagram. So 1x is 40, and this one here would be 80. The question asked us to work out the size of BCD, so we've got that straight away. That would be the 40 degrees. So our final answer is 40 degrees. And there we go, another relatively nice version of a question. Yes, you need to know about your opposite angles in a cyclic quadrilateral, and you needed to apply a little bit of algebra in this question, which is slightly different to some other circle theorems, but overall, I think quite a nice circle theorem question. Again, as I said, I will link some circle theorems in the description so you can have a look at some of the hardest types of circle theorems as well. but we are still relatively early on in the paper, even at question 17. So our next question is looking at an iteration. This question here says using xn plus 1 is equal to the cube root of 10 minus 2 lots of x with the little n there, with x0 equals 2, find the values of x1, x2, x3. So this is our iteration formula, and that just means to find the next number in the sequence, we need to do the cube root of 10 take away 2 lots of the current number that we are using. And it tells us to start with 2, and that's what x0 means. So to find x1, we are going to do the cube root of 10 take away 2 times 2. And again, we're just going to type that into a calculator. So 10 take away 2 times 2, and that gives us quite a long decimal. We get 1.817120593. Now I do recommend writing all those numbers down. The only time I would shorten it is if it does go off the screen and there's a very long recurring decimal. I'd only necessarily write it up to this length. For x2, we're going to take a little bit of a shortcut. So we've got the cube root of 10 take away 2 times our current number is now that big long decimal. So I'm just going to put my answer button in so that I don't have to keep typing this. So I've just gone into my calculator, deleted this 2 at the end, and changed it for my answer button. I can now just press equals, and I get 1.853318496. And the really nice thing now, I don't even have to do anything. I just have to press the equals button again, and it's going to put that previous answer in, and I'll get my final answer for x3, and it comes out as 1.846265953. If you'd like to see me doing this on a calculator, I will link in the description as well how I've done this on a calculator and some different methods you can use, which might be helpful for some slightly harder iterations when you might want to store the numbers within your calculator as you go through. But there we go, there is our iteration question. I do need to write them on that dotted line. I'm going to leave them there for this, just so that I'd have to rewrite all of those again, but obviously always write your answers there on the dotted line. So there we go, that's our iteration question. Now this one has a part B, and it says the values of x1, x2 and x3 found in part A are estimates of the solution of an equation in the form x cubed plus ax plus b equals 0, where a and b are integers. Find the value of a and the value of b. So we need to get that equation from up here. So it was x with the n plus 1 is equal to the cube root of, and it was 10 minus 2 x with a little n. Now, when we are rearranging this back into the original equation that it was, I'm going to first remove these little letter parts down below. So I'm going to rewrite the equation. It's x is equal to the cube root of 10 minus 2x. Now, all I actually want to do is make it equal to 0. As soon as it's equal to 0, it's going to look like that equation above. So the first thing to do is I need to cube both sides of the equation. That's going to get rid of the cube root. So I get the x cubed is equal to 10 minus 2x. And at this point now you'll see, particularly if you're good at rearranging formula, that this next step now is relatively nice. I've just got to add the 2x to the other side. Once we do that, we get x cubed plus 2x is equal to 10. And to make that equal to 0, I just need to minus 10 to the other side. So x cubed plus 2x minus 10 is equal to 0. So in the question up here, a was the number in front of x, which in our equation here is 2. So a is equal to 2. And c is, or b, is the number at the end, which in this case is negative 10. So b is equal to negative 10. And there we go, there is our iteration question and a bit of rearranging, actually in reverse, because quite often you'll have questions that ask you to do this the other way round. But there we go, there is that question on iteration. Now question 19 says that the curve C has the equation y is equal to x squared plus 3x minus 3. The line L has the equation y minus 5x plus 4 is equal to 0. Now it says show algebraically that C and L have exactly one point in common. So for this question, we are essentially doing a quadratic simultaneous equation in essence, but we do not have to use a substitution method for this. So to start with, we look at our first equation and it's given us y equals. Now this second equation, as there's not a y squared in this one, we could also write as y equals, but to get it into that form, we're going to need to add this 5x to the other side and minus the 4. So if we do that first and rearrange this equation, we get y is equal to, add 5x to the other side and subtract the 4, y is equal to 5x minus 4. We have the first equation, which is y is equal to x squared plus 3x minus 3. So if we set these two equations equal to one another, we can actually just solve it from there. So a different version of a quadratic simultaneous equation. So it is a simultaneous equation here. We have a quadratic in the second equation and a linear equation in the first one. So if we set them equal to each other, I'm going to put the x squared equation on the left. That's just personal preference. And that's equal to 5x minus 4. You can set them equal to each other because they are both equal to y, so they're both equal to each other. I now want to solve this, and it is a quadratic, so I want to make it equal 0. So I'm going to minus 5x from both sides. So that gives me x squared minus 2x minus 3 is equal to negative 4, being careful there to still include the negative. Then I want to add 4 to both sides. That gives me x squared minus 2x plus 1 is equal to 0. Now at this point here, I want to obviously solve this. Now if it doesn't factorise, you may have to use the quadratic formula. But if it does factorise, which this one should, I think it's 1 and 1. And in brackets, that would be x minus 1 and another x minus 1. And there we go. So it factorises into the same two brackets. That means here that our solution for x is 1. And in the other bracket, our solution is also 1. So we have exactly the same solutions for these two, meaning that there is only one set of coordinates or one root that we can actually have to the solution of this equation. Don't forget, this could be written, and I've not written it like that, but this could be written as x minus 1 in brackets squared is equal to 0. And that's one of those scenarios there where we just get the same root for the equation. Now what you could do is you could substitute the x coordinate back into that y equals 5x minus 4. That would give us the y value as well. So y would be equal to 5 lots of 1, take away 4, so y is equal to 1. 5 times 1 is 5, take away 4 is 1, so we have a solution of x is 1 and y is 1. Now that means, and we should sort of write a statement here, that we say something along the lines of there's only one root or one value of x, so there's only one coordinate where these cross over or they intersect, which is what we are looking for. So here we go, we would say something like only one solution or only one root, and you could write something else if you wanted, so there's only one set of coordinates where they cross over. But there we go. There is our quadratic simultaneous equation, a little different. Again, a relatively nice one if you've done these ones before where you have them and you can set them equal to each other. A lot of people do a lot of focus looking at the hardest type of questions. And again, I will link the harder questions in the description so you can have a look at some really horrible ones. But just so you are aware, you can have some slightly different ones as well. So for this question, we are rearranging the subject and we want to make A the subject. We have an A on the left and we have an A on the right. So when this process happens, we want the A to be on the same side. So to do that, we need to first multiply this denominator R over to the other side to unlock the A on the top of that fraction. So when we do that, we get R lots of A plus 3, and that's equal now to 2A plus 7. You can expand that out straight away if you're sort of confident with these. I'm going to expand it out, so 8R plus 3R equals 2A plus 7. I now want the A's on the same side, so I'm going to minus 2A from both sides. And if you're confident doing this in one step, you could also minus the 3R at the same time. Now, I am choosing to move the A's to the left, and that's just personal preference. But if you choose to move the A's to the right, that's fine, but you'll get a slightly different answer to me here. So I'm going to move the a's to the right, so I get AR minus 2a, and that's now equal to 7 minus 3r. And you can see all that's happened is the 2a has moved over to the left, and the 3r has moved over to the right. From here, I've only got sort of one step to kind of get close to finishing it now. I just need to factorise the a out. I get r minus 2. As we've just factorised a out, a times r is ar, and a times 2 is 2a. That's equal to 7 minus 3r. And to finish it off, so that a is on its own, isolated, and then the subject, we just divide by the bracket r minus 2. And there we go, that was our final step. We're dividing by r minus 2 on both sides. And there we go, a is now the subject, and that's the little formula there that we want to write on our dotted line. So a equals 7 minus 3r over r minus 2. And if you do rearrange it so that the a's are on the right, yours will look ever so slightly different to that. But again, still an absolutely fine answer. You don't have to rearrange the subject to one particular side. Okay, on to question 21. It says a solid cone is joined to a solid hemisphere to make the solid T shown below. So this whole shape here is solid T. It says the diameter of the base of the cone is 7 centimetres. The diameter of the hemisphere is 7 centimetres. The total volume of T is 120 pi, and the total height of T is y. Calculate the value of y, and give your answer to 3 significant figures. So we know we're not going to get a very nice answer here. But if we look at the cone and the sphere, and again looking at the formulas that we are given, we need the radius for both of those. So straight away I want to write next to this that the radius is half of 7, which is 3.5. So I've got the radius. And also not forgetting the radius of a hemisphere is this height just here. So this is also 3.5. So part of the height of y that we have here is 3.5, and therefore the height of the cone, if we wanted to write that as an expression, which we might need to, would be y subtract 3.5, the remaining height there. And let's put that into a bracket. So y minus 3.5. So in order to work out this height of y, we need to think about using the formulas for the volumes. We would do the volume of a sphere, we would halve that, and we would add that to the volume of the cone, and it's giving us this answer 120 pi. So if we put all these pieces in place, let's see what it looks like, and it might be a relatively long bit of writing here. Now the first thing that I'm going to do is I'm actually going to change this formula for a hemisphere. So 4/3 for a full sphere, half of 4 is 2, so it's 2/3 pi r cubed for a hemisphere. You can also write that as 1/2 times 4/3, but I think it's relatively nice to look at that and just think, well, half of 4/3 is 2/3, and then just use that formula instead. So there we go, that's only for a hemisphere though. So let's have a look. So 2/3 pi r cubed for the hemisphere. So we have 2/3 times pi times the radius cubed, and the radius is 3.5. So 3.5 cubed. I'm just not going to write lots of time signs in at the moment because I think this is going to be quite a long one to write. We're going to add to that the volume of the cone. So that's 1/3 pi r squared h, and we don't have the height. In fact, well, we do, but we've written the height as an expression, y minus 3.5. So we'll use that expression down here. So plus 1/3 pi r squared times the height, so 1/3 pi 3.5 squared times by the height, which is y minus 3.5, this expression that we are using for the height. Keep that bit in brackets, y minus 3.5. And that's equal to 120 pi. Now that is a very long sort of expression, formula, equation that we've sort of written down there in terms of writing all of these pieces in place. So on the left here, we have the volume of the hemisphere. I'm going to label all of these. Volume of hemisphere. In the middle, we have the volume of the cone. We're adding those together because that is giving us the total volume which the question gave to us. And there we go. Maybe that makes a little bit more sense sort of looking at it there. So in order to solve this, remember we want to know the value of y. That's the whole question. Work out the value of y. We want to be able to isolate this piece. Now to do that, the first thing is let's subtract the volume of the hemisphere. So let's minus this 2/3 pi 3.5 cubed over to the other side. So minus 2/3 pi 3.5 cubed. I'm going to write this out a little different when we come to the point of putting it in a calculator. So that leaves me with a 1/3 pi 3.5 squared with my height y minus 3.5, and that's equal to 120 pi minus 2/3 pi times 3.5 cubed. Okay, now this looks a little bit more complex on the left, but if it was, for example, 3x, and I know the x there is my expression in the brackets, well, that would look a lot simpler, and we'd know, okay, we just divide by 3. We can do the same process here. We just divide by all these things in front of the bracket. They're all getting multiplied together, so we can just divide by all those things. So I'm going to divide by 1/3 pi 3.5 squared, and that will just leave me with y minus 3.5 on the left is equal to, so we have 120 pi, is a lot to keep writing out here, 2/3 pi 3.5 cubed all over 1/3 pi 3.5 squared. Now I say it's a lot to write out there, but actually it would take a lot longer if we wrote these all out as the big long decimals that they actually are represented by. So although it seems like a lot of writing, it's definitely a lot easier to write it down in this way than it would be to write out those long decimals and keep it all like that. So for this one, this point, I'd probably add the 3.5 over as well. In fact, I'm going to work it out and then add the 3.5, otherwise I'm going to have to write all of that out again. So I'm going to have y minus 3.5, and then I need to type all of this thing in the calculator. Let's just have a look at how we type it in. So 120 pi, I can write exactly like that. Take away 2/3 using my fraction button, pi. And I do need to put a multiplication symbol in here. It might work on some calculators, but typically it only allows you to put one number with the pi symbol before the calculator sort of has a bit of a freak out. So I'm going to put times 3.5 cubed. On the bottom, I've got 1/3 pi times 3.5 squared. And again, I'm putting that time sign in. And lovely, that does give me an answer. It's happy with that. And it came out as 22.3877. I'm going to press my S to D, my conversion button. I'm going to write out the shorter decimal, 551. There we go. So there is a recurring decimal version as well, but I've just used that version there because it only wants the answer to 3 significant figures, so I've got it to tons there. Right, I can finish this off. I just need to add 3.5 to both sides. That will isolate the y. So I've got y is equal to, add 3.5 on my calculator, get rid of that recurring decimal version, I get 25.8877551. Okay, so a lot of steps there, a lot of pieces to put into place, but let's finish it off, rounding it to 3 significant figures, which is 258, so chopping it after the 8, so y is equal to 25.9. And there we go, that's my final answer there. That might be one that you want to have another look at. I think the difficulty in that question was actually the very first step where you're writing this expression for the height and substituting that in. You wouldn't necessarily have to do it like that. There's definitely another way that you could do this. You could maybe just use y in total. No, I think that's the only way that I would do it. I think definitely writing the expression there for the height of the cone is the difficult part of that question. But there we go. Other than that, even if you didn't get that expression right, you could still pick up a lot of marks here just by putting all of the radiuses into those formulas and sort of finding the volume of the hemisphere and the volume of the cone. Even if you couldn't put the height in straight away, you could still get pretty close and start to rearrange it. But there we go. There is sort of a mixed volume question looking at cones and spheres. Okay, so question 22. So for this one, we have some bounds, and the bounds are including compound measures. So this one here we have speed, distance and time. So it says here a race is measured to have a distance of 10.6 kilometres, correct to the nearest 0.1. Now straight away, as soon as I see that, I'm going to write the error interval down. So the error interval for the distance, if it's correct to the nearest 0.1, well that'll be 10.65 on the right there for the upper bound, and 10.55 for the lower bound. Sam runs the race in a time of 31 minutes and 48 seconds, correct to the nearest second, and his average speed is v kilometres per hour. Okay, so this is in minutes and seconds, and this is kilometres per hour. This isn't going to be a very nice one at all, but let's have a think about how we could do this. So this is by considering bounds, calculate the value of v to a suitable degree of accuracy, and you must show you're working and give a reason for your answer. So where we are considering bounds as well, we need to do the upper and the lower bound and have a look at how they round the same. So if we are looking at speed, distance and time, to work out a speed, we've got to do a distance divided by a time. So we need to take that into account, but when we are looking for the upper bound, I'm going to have an upper divided by a lower, and for the lower bound, I'm going to have the lower divided by the upper. So we need to write the error interval for the time here to start with. So for the time, and I think I'm going to need a bit more space, but let's just have a look. So we have correct to the nearest second, so the lower bound of the time would be 31 minutes and 47.5, half a second below the 48 seconds. I'm going to leave it like that for the moment. And then the time, and then the larger bound here will be 31 minutes and 48.5 seconds. Now in order to work out the speed here in kilometres per hour, I'm going to need these times in hours. So to convert these into hours, I'm going to first want to convert this into seconds. Because we have minutes and seconds, it's a real pain. So let's start by multiplying the 31 minutes by 60 and then adding on this additional 47.5. I'm going to do the same on this side. Again, there might be other ways that you spot here that you can use. I think this is quite a nice logical approach though. So adding the 48.5. So 31 times 60 is 1,860 plus 47.5, all on the calculator, and that comes out as 1,907.5 seconds. For the right, we have 31 times 60, of course, because there's 60 seconds in each minute, and then add 48.5, and that comes out as 1,908.5 seconds. So they are the bounds there in seconds. But we want to know that in hours. So I can start by reconverting it back into minutes by dividing by 60. And I can do that to both sides. I'd probably just do this in one step, divide by 60 and divide by 60 again, because I'm going to get some pretty nasty numbers here. But let's just write all the steps down. So that'd be 31.8083 minutes. And I need to divide it by 60 again to turn that into hours. I'm not getting the nicest numbers here at all. I think in an exam, this sort of stage here would really start to put me off because these numbers just don't look like they're going to be right, but they are right. They're just not very nice numbers. So there we go. That is the time in hours. And it makes sense because 31 minutes is just over half an hour, isn't it? So just over 0.5. So logically, our answer does make sense. We do have this recurring 8 at the end, which is a bit of a pain because we're going to have to try and type that back in using the recurring decimal button. It's not the end of the world if you don't, because it's in the 6th decimal position. It's not going to be awful. But let's do the other one. So 1907.5 divided by 60. That comes out as 31.7916, another recurring decimal there. Minutes, I'm going to straight away though divide by 60 again. And when I divide by 60 again, we get 0.529861, and that is in hours. There we go, and that is the decimal at the end. Okay, so we've got all of our pieces. We have all, I mean, it took enough work just to get these numbers in hours, but I think the next step's relatively nice. So to get the upper bound, we want to do, and remember we're doing speed is equal to distance over time. So I want for the upper bound of the distance divided by the lower bound of the time. That's the biggest number divided by the smallest number. For the lower bound, I want the lower bound of the distance divided by the upper bound of the time. So in terms of the upper bound of the distance, that was 10.65. So I have 10.65 divided by the smaller time, which was 0.529861 with a recurring 1. And for the lower bound, I want the lower bound of the distance, which is 10.55, and that's over 0.530138. Okay, so I just need to type those into the calculator. So for this first one, I get 20.099606682. And for this right one, 10.55 over 0.530138, I get 19.900445338. So I have my upper bound and my lower bound. And it says here in the question, by considering bounds, calculate the value of E to a suitable degree of accuracy. You must show all your working and give a reason for your answer. So I need to figure out, by looking at these two numbers, how they are both going to round to the same number. So if I look at the two numbers, you can see even before the decimal point there, those numbers are different. So one's a 20, one's a 19. So I'm not going to need to go super accurate here. I'm not going to need to go into the 3 decimal place positions because they're not going to round the same to 1 decimal place. To 1 decimal place, one of them's 20, one of them's 19.9. So I'm going to have to go even less accurate, so just to here. So on the left, this number rounds to 20. That's to 2 significant figures, or you could say to the nearest whole number, but we'll use significant figures. And on the right, 19.9 also rounds to 20. So to 2 significant figures, we get the answer 20. So for this one here, I would say 20, and my reason would be to 2 significant figures. There we go. I've just put something along the lines of both bounds round to 20 to 2 significant figures. And there we go. That'd be our final answer. Not all bounds questions are quite as complex as that, but that one there involving some speed, distance and time, where the time was given to us in minutes and seconds and having to convert it all into hours. Not a very nice question at all, but that process of the bounds, using the bigger divided by the smaller and the smaller divided by the bigger, and potentially having to consider bounds and round it all at the end. There we go, quite a common calculator style question, but definitely a difficult one there, where we had those minutes and seconds to convert. So there we go, that was some bounds calculations, and now we have a question on trigonometry. So it says here, ABC is a triangle, D is a point on AB, work out the area of triangle BCD. So the triangle we need the area of is B, C and D, this one here. Give your answer correct to 3 significant figures. Now, before we get started, in order to work out the area of this triangle, we need 2 adjacent sides to one of the angles. So if, for example, I use the angle of 25, I would need this side here, let's put a question mark next to it, and I would need this side here. And we don't have any other information in that triangle other than the angle. So there's probably going to be quite a lot of steps, and I like to sort of look at this question and think through what I have to do. I'll probably be able to do it relatively quick, otherwise this will take me, these could take 10 to 15 minutes really, actually looking at the amount of working that needs to be done. So I'm going to try and go as fast as I possibly can. So you might want to slow it down if you watch this. So for here, opposite this angle, I can work out that side, and I can do that using the cosine rule, and that is going to be my step 1. Once I have that side, I'm going to also need to find another side, another angle within this triangle on the left. Now ideally, I'm going to look for this angle here, because then I can do angles on a straight line to get this angle. So once I have that opposite side, this is going to be my step 2. So here, and I'm going to use the sine rule. So I'm going to label this up. I'm going to use the cosine rule here. I'm going to use the sine rule for this angle. I'm going to use this, I'm going to do angles on a straight line. I'm just going to put a little diagram here, which I use for a straight line. So straight line equals 180. Once I've got that, I can then figure out one of the other angles, because I'll have angles in a triangle. So I'll be able to work out this one. So angles in a triangle equals 180. A couple of these steps here aren't actually that bad. They're just angles on a straight line, angles in a triangle. Once I've done that, I'll have enough information to use the sine rule to find this angle, or this side. No, I've got that side. So I've got these pairs. I'll be able to find this side. There we go, using the sine rule. That's going to be my sort of, what was it? This was step 4. That's going to be step 5. It's going to be the sine rule. Then I'll have the side that I need, and step 6, I can work out the area of the triangle. So this is a huge question, and planning it out like that is not easy to do. So, right, let's just have a look then. So for step 1, and I'm going to get rid of all this working out. If you want to sort of screen grab that, you can always do so as you're watching it, but I've got a lot of steps here to do. I just wanted to think my way through the question before we get going. Right, I should be able to do it pretty quickly now. Now, if you know the sine rule, the cosine rule, and the area of a triangle formulas, well, in terms of how to use them, then each individual step is not horrible here. But I need to first use the cosine rule, so a squared is equal to b squared plus c squared. Now, if this is my a, this will be my b and c, and I do move my letters around for every stage that I do this. So 3.8 squared plus 4.9 squared minus 2 times 3.8 times 4.9 cos of 80. And there we go. To find the value of a, I like to just square root everything in one go so I don't have to keep writing it all down. So a is equal to 5.65538163. I'm going to label that on the diagram so I know I've got that. I'm going to get rid of all my a's and b's because I don't need those anymore. In fact, I don't need any of this. There we go. So it can help to sort of rewrite this diagram, particularly when you're doing it because it does get a bit messy otherwise. I'm going to write it up to 3 decimal places. I want my answer to 3 significant figures, so I've kept it to 4 for the moment. I should probably put another one in, but it's a 3. I'll put that one in as well. So now I've got that, I can move on to step number 2, which was to work out this angle here so that I could move into that right-hand triangle. To work out that angle, I'm going to use the sine rule. So I've got this pair of opposites here and this pair of opposites here, obviously with the angle being the one that I need. So for the sine rule, I want sine of the angle that we're looking for. Let's call this one big A, so little a, and then this one big B and little b, ignoring the letters on the diagram. You can swap around the a's and b's if you prefer to keep them. So we have sine A over 4.9 is equal to sine of 80 over 5.6553. Now I'll try and use that full number in my calculator as I do it. Now to rearrange this, I need to first move the 4.9 up to the numerator here, so it'll be 4.9 sine 80, and then I need to do the inverse of sine. So I'm going to do sine minus 1 to find the angle, and I'll have 4.9 sine 80 over 5.6553. And there we go, I'll type that into my calculator. That's going to give me the angle. It comes out as 58.568949. So that angle there, and if I get rid of the A now, get rid of all these arrows and all these labels, and that one there is 58.568. And then a few more, but I'm going to leave it there. I can now work out this angle next to it on the straight line. So I can take that away from 180, and that is equal to, on the calculator, 121.431. I can now work out the missing angle in the triangle, this one here, because the 3 angles on this right triangle, 25 and 121, leave me with one missing angle. So 180, take away 25, take away the 121, that leaves me with 33.5689. There's 49 after that as well. There's a few more decimals, but there we go, 33.5689. I'm almost there, okay? And I've done some of these steps quite quickly. I've rearranged in sort of the fastest way possible as well. But for this final step, where I need to get this other missing side, I'm now going to use the sine rule again. And again, I can use, I don't have the other side down there, so I have to use this pair of sides here. So I'll do that up here. We're looking for a side this time. So it's A over, and let's call this A, and this one B, which already has the B on it. So A over sine of 121, not close brackets, 121.431 is equal to B over sine 33.56849, and we actually have that value of B, so I didn't need to write B there. Our value of B is that 5.6553. I have the same step essentially of working out here. I need to move either, let's have a look, the 5, now I need to move the sine 121 up to the numerator, so that'll go at the end here, so sine 121.431, and that gives me A is equal to 5.6553 sine 121.431 all over sine of 33.568949. I do wonder when I'm doing this how many decimal places I really need to do and what could I actually get away with if I round this, because it seems like a lot of writing when you do these questions sometimes. But there we go, typing that in, we get A is equal to 8.7267. I'm going to leave it there, 8.7267. I've only got this one over here to 4 decimal places, so I'll keep that to 4 decimal places as well, and just hope it doesn't affect the answer too badly. It shouldn't do. So there we go. I've got all the side lengths that I need. I now just need to do the area of a triangle. The area of a triangle formula is half AB sine C. So again, let me just get rid of these labels that I've already got on there so we don't confuse any of the letters. I'll swap to a different colour. So half AB sine C, so this is going to be my big C. How nice of them to label that with a C. And then we have A and B here. So half AB sine C. So we have a half times A, which is 5.6553, times B, which is 8.7267 sine 25. There we go. I'm glad that fit on the page there. It would have annoyed me otherwise. And there we go. We just need to multiply all of that together. That is going to give us our area. We are basically done now with this question. That comes out as 10.4279 to 3 significant figures. Drop it after the 4. So that is 10.4. It is an area. It is in centimetres. So centimetres squared. So that was a trigonometry question that literally involved everything. It had the cosine rule for a side length. It had the sine rule for an angle, the sine rule for a side, and the area of a triangle formula. So it didn't use cosine for an angle, and it didn't use any reverse area of a triangle, which you can have as well. So only 2 bits of trigonometry actually missing from that question. The cosine rule for an angle, and the reverse area of a triangle, where it gives you the area, and you have to find a side or an angle. So lots of difficult bits of trigonometry. So there we go. That question could easily take 10 to 15 minutes. Hopefully I've not spent too long doing that question there, as I do know it can seem like I'm sort of doing a question for ages, but this kind of question does require that amount of time, and it is the last question on the paper, so it was meant to be a very difficult question. It's 10.4. Obviously, the only thing that I wouldn't recommend is sort of skipping some of the rearrangement steps like I've done there, like unless you're very, very confident with it. So for example, here where I've jumped from there to there, I would have written the 4.9 sine 80 first and then done sine minus 1 maybe of my answer, or sort of written down a few extra steps there. But there we go. There is the trigonometry question to finish the paper. Well done for sticking all the way through the paper there. And that is the end of our paper 3 revision videos. So there we go, that's the end of the video, and I guess before we finish, I'd just like to wish you the best of luck with your final exam paper. I do hope to hear from you on results day, so please do drop in, let me know how you've done on results day. But otherwise, this is our last revision video, and of course, ideally, if everything goes to plan, I won't see you again on another GCSE video, but I might have some A-level videos that you might be interested in next year, so do watch out for those and let me know. Obviously next year, if there are any specific topics or videos that you'd like me to sort of go through if A-level maths is something that you're going into. Hopefully it is, particularly if you're answering this question at the end of the paper and you've stuck with me to this point. I would imagine that you are somebody which is maybe considering at least going into A-level maths, and I certainly hope you do make that decision to choose to do that if you are sort of answering these types of questions. But there we go. As I said, hopefully won't see you again for another GCSE video,
your revision under control and you are making great progress towards paper 1. But if you're struggling to know where to start and need to maximise your maths in minimum time, then you should sign up for my rapid revision programme, Upgrade, as you can use it to build your very own personalised revision plan. Which means all you need to do is complete my revision quiz and you'll know exactly which lessons or topics you need to work on to maximise your maths in minimum time. This is my paid programme, but you can sign up for a free trial on my website now. And if you feel like you need top tier support direction from me, then sign up for my live weekly interactive lessons, which include revision specific lessons focusing on the topics that I expect to appear in exam papers 1, 2 and 3.